Hey everyone, I'm Ben Potter, the security lead of Well-Architected for Amazon Web Services. This session is Security Best Practices the Well-Architected Way. We're going to be starting off with the foundations to what makes a secure workload in AWS, then running through the different areas, finishing off with incident response. In incident response, I've got a demo of a semi-automated playbook for you to play with. So Well-Architected has been around for over 8 years now, and it helps you build secure workloads and architect in the cloud. We have white papers available across many different pillars, in which security is one of them. And we also have a tool in the console which you can help to learn about best practices and measure your architecture that you're running and also improve it over time. Let's start off with the security foundations now. And really, we want to start off thinking about our AWS account structure. So using organizations to manage multiple accounts. And it's multiple accounts that you need to use to isolate different aspects of your environment running on AWS. So we can start off with an organization's management account. This management account runs organizations and other services like Control Tower. Control Tower can actually automatically deploy guardrails for your entire AWS infrastructure. We can also have other services running in this account like single sign-on or SSO. We should also consider using a log archive account. So this account doesn't have any access except read-only access from other accounts. So our logs are stored here very safe and secure if we need to get back to them. And it's the critical logs like CloudTrail and config that you want to store in the service. And Control Tower can actually set up this log archive account for you. Then we want to centralize our operations. So this could be a central security operations account, which can then reach into other accounts. And it's services like GuardDuty, Security Hub, that we can run in this central operations account. Then we can have our workload account. This is where we run our applications. And we want to at least have a separate account for development for an application or a workload and a production account. So this is where we're running our services that do things in our accounts. One best practice is employing guardrails on your AWS account. And the guardrail I have in the example here is denying the creation of any IAM users or access keys. And I'll touch on why this is an important guardrail to implement in the next section on identity and access management. So you also want to start with a threat model. So identifying and prioritizing your risks using a threat model will help you work out where you need to put more effort into in protecting your workload. You also want to stay up to date with what's going on out there and make that relevant for the applications that you're using. For example, if you're using WordPress, then you should stay up to date with any updates to WordPress, any patches that are available, and any best practices that come out for that. And of course, AWS. And I have a number of links down the bottom there that you can follow to help keep up to date with AWS. So throughout this session, I'm going to be using an example architecture that I'm going to build upon. It's a very simple web application that's internet facing. I have instances, a Aurora cluster, our Lambda function, storing data in S3 and using simple notification service for alerting. Let's get into identity and access management now. We want to build upon this simple architecture. We have our operations account down the bottom there, and that's where we're running a Security Hub. That's where we're running organizations and Control Tower. And this is also where we can configure single sign-on. And it's a best practice to centralize your identities. So instead of having IAM users running in each individual account or manually creating cross-account roles and across all your different accounts, centralizing using single sign-on will help you manage multiple accounts more securely. You also want to use strong sign-in mechanisms like multi-factor authentication and having complex password policies as well, where it's appropriate, and of course rotation of those passwords if it's appropriate for your use case. So this is all about workforce identities, or people like you and I that need to access your AWS account for day-to-day management and operations. You also want to audit the credentials that you do have. So let's keep going on these key best practices. You want to use temporary credentials. So if we're using SSO for you or I as a workforce identity, we're going to be using temporary credentials by default, automatically in the console. For our application though, the instances running, the Aurora cluster, the Lambda functions, we can assign a role to these and they're going to get temporary credentials from the STS service. Where we have a service like the Aurora and we need a database password, we need to store that database password securely and automate the rotation. We can use Secrets Manager to do this. And there's many good examples on how to do this. What we're trying to do here is not use any long-lived credentials and automate as much of this as we can. We don't want any IAM users or access keys laying around anymore. For workforce people like you and I, we can get access to the command line interface through the integration with SSO. And in my demo, I'm going to show one example of how to do that. For permissions management, we want to share the resources that we have. That's EBS snapshots, buckets, cross-account roles securely. And we can use Resource Access Manager to do that. We also want to analyze that public access and the cross-account access that we have. And in doing so, we want to grant least privilege as well. We don't want to grant any privileges that are more than necessary. We don't want to get lazy. We've all done it before with granting staff or administrative privileges where it's not required. So speaking of least privilege policy, I'm going to build out an example of how you can use conditions as a fairly recent condition that we can use for services accessing other services. So you can see here as I build out the policy, we have effect of allow, action of getting objects and getting bucket location. The resource is the bucket and the object prefix. And then we have our condition, which is using called via Athena. So Athena can use this policy for granting access. And you can find out more on that blog post link about this one example of a condition use. Let's move on to detection now. So we have our sample architecture. What we want to do is configure service logs, that's AWS service logs, as well as application logs to log centrally. And we want to tie this in with other metrics and findings from services like GuardDuty and Security Hub. So we get that full visibility of what's happening across all our different AWS accounts. At the application layer, we want to configure logging at both the application and the operating system layer. And these can be done on the instances using CloudWatch and the CloudWatch agent. For Aurora, we can enable database logging to go through to CloudWatch. And of course, the Lambda functions can also log into CloudWatch. Then also think about how critical these logs are for you. Do you want to then push them into a log archive account or keep them in that single account for analysis? So then think about ways to verify your architecture and what you're running. And Security Hub, using the new foundational checks, can help you do this. And a number of these checks align to the well-architected best practices as well. So you can check out the link down the bottom there. Now, one thing I like talking about is actionable security events. So where you've got all these different services like GuardDuty and Security Hub, you could just be configuring email alerts, but those emails are going to get lost, especially if they go to large aliases. What we want to do is make them actionable. So enabling an instant chat or message integration, so I'm using Chime here as an example, you could use Slack or something else, enables people to investigate it and respond to it in a thread. They can also look at other information surrounding that incident. For example, you could give them a link to the runbook to go through. Also fairly recent, we've released conformance packs, and conformance packs that run in AWS config can help you look for well-architected security best practices. The conformance packs are actually written in YAML and open sourced on the link below. So I encourage you to go and check them out. Conformance packs can also do automated remediation for you to help you remediate any misconfigurations that you do. So let's go into infrastructure protection now. So I've zoomed in on this account that's running the workload. What we want to do is implement network layers. So we want a multiple layered strategy, a bit like an onion. And the more you get into it, the more you're going to cry as an attacker. So you have an internet connection, an internet user, that will resolve DNS through Route 53. And of course, you can go back and configure logging on the Route 53. So you get an insight onto who's looking up DNS requests. Then the traffic will go through to CloudFront. CloudFront as a content delivery network also integrates with the web application firewall service. So you've already seen this multi-layered defense here using both CloudFront and web application firewall. These are edge services, so these scale across the globe. Then we're going to build out our VPC and what multiple layers look like in our VPC. So we have a load balancer layer, which is in the form of multiple subnets running across availability zones. And this is where our application load balancer can live. We can then have a DMZ or shared layer. And if our application needs to reach out to the internet, this is where our NAT gateway can live. And then we have our application layer. Now this has no direct internet access at all. The only way that you can get into it is through the load balancer layer, through CloudFront, through WAF. And of course we can enable WAF at the load balancer layer as well. And then finally we have our database layer. And this database layer has no internet connectivity at all. It doesn't need to reach out to the internet for any reasons, and it doesn't need to accept any connections from the internet, only allowing connections from the application layer. Missing from this is a fairly new service is the network firewall. And the network firewall will add an additional layer of defense at the VPC layer. You also want to control the traffic at all layers. And we can do this using security groups. And each subnet can have its own network access control list or NACL. That is a coarse-grained way of controlling the access between the different subnets. And each of the different subnet layers, we can also have a different route table. For example, the database tier doesn't need access to the internet, so it doesn't have a route to the internet, even through the NAT gateway. We just don't allow it in the route table. It doesn't exist. There's no way for it to route in or out of the internet. At the end of this session, I've got some links to labs. We actually have a well-architected lab that can build out this example VPC with an example web application for you. We also want to implement inspection and protection. And this is where the network firewall also comes in. And you could optionally look at configuring agent-based or partner solutions as well. And of course, to make it easier to manage and configure all of this, you can use CloudFormation to stand up all this infrastructure for you and deploy secure templates. And it's actually a CloudFormation template in our labs that can help you build this. You also notice I don't have any Bastion hosts or external access for managing the instances. We want to do this using tooling only, completely hands-off management using Systems Manager. We also want to reduce the attack surface and do vulnerability management. So we can use Inspector for looking at what vulnerabilities and exposures are available as terms of patching. We also want to build hardened or secure images. We can use Image Builder for this. If we're using containers, we could use ECR for this function as well. We also want to validate the software integrity to help ensure that you're getting the software or the libraries or modules that you wanted to from the developer by verifying checksums or their certificate or other mechanisms that are available to you there. Let's go into data protection now. So one of our design principles is keeping people away from data, and you'll hear our CISO Steve Schmidt talk about this a lot as well. Firstly, think about, do you need to store the data in the first place? And how can you grant or not grant access to that data? Keep it completely isolated away. And if you really do need to store it in the first place, then think about how you're going to encrypt it, mask it, or tokenize it. Then you want to eliminate any direct human access to it. And that's going to reduce the risk of any accidental use of the data or touching of the data as well. And then think about the tooling that you can employ to enable that no human access. So doing operations as code, for example, the CloudFormation I mentioned before for standing up the infrastructure, rather than one of your administrators clicking around in the console who might make a mistake. And all this code can be version controlled and peer reviewed as well. And this is really where the term DevSecOps was coined. So let's go back to our architecture now. It's important to know what data you're actually storing. And for data in S3, Amazon Macie can help you with this, identifying the data that you are storing. Also think about how you're doing encryption. So using KMS for service integration. In many services, it's just a tick box that you can enable. If you need to do encryption yourself, you can look at the encryption SDK, which integrates with KMS. For data in transit, you can enable no-cost certificates, both in CloudFront and the application load balancer, using Certificate Manager. So that's going to encrypt the data in transit with TLS for this web application. Also advise you look at enabling default encryption. So the screenshot on the left is the simple enabling of default encryption with a KMS key in S3. And the screenshot on the right is using default EBS encryption, which applies across an entire region in that account. So very powerful and very easy to enable this encryption. And of course, a little trick for EBS encryption is to use your own key that will enable cross-account sharing of snapshots. Otherwise, if you use the built-in KMS key, you can't share those snapshots across accounts. Right, let's dive into incident response now. So it's really important that you have incident management plans in the form of playbooks or runbooks, and perhaps also escalation plans. And the amount of planning that you do depends on the industry you're in and what your risk appetite is. You know, if you're a startup, then you're going to have a lot less planning in that in incident response than, say, a financial institution does. So if you are just getting started, I recommend looking at using Markdown. And I have a very, very simple playbook or runbook that's written in Markdown here for you. So starting with scenario title and description, any actions that you're going to take, and any escalation paths that you need to do. We've actually open sourced a couple of runbooks and continue building on these on GitHub on the link below. So go check them out if you're just getting started. So how to run a game day. So it's really important that you simulate event response. So everyone in your teams knows how to act and knows what to do in an incident. So starting off with planning a game day, it can be just a couple of hours here and there. It could be a full day event. I'd like to recommend finding a prize. So this can be as simple as stickers. Have some virtual drinks and food to make it a bit of a team collaboration effort. Then, if you don't know where to get started, pick guard duty finding. maybe one that you've already come across before, and then work on your plans. Starting off with the simple markdown plans, how are you going to investigate that incident? Work together on it as a team, then iterate, learn from each other, how you go from there. And then, of course, make it fun so you go back and do it again. So it's really important that you practice incident response. Otherwise, you're not going to know where any gaps exist. It's also important to pre-provision access. So if you have our security operations account, we can have our playbooks running in there, or stored in there, I should say, and our other tools. So I have Amazon SageMaker here as a service that I've used to start building automated or semi-automated playbooks using Jupyter. And the demo that I'm about to show you will use Jupyter for that. So SageMaker is a really easy way to get started for that. Also, if you have logs just sitting in S3 that you need to quickly get access to, then Amazon Athena is serverless, can query those S3 logs for you. And there's many examples of how to query CloudTrail logs, CloudFront logs out there on the internet as well. Of course, we can use Lambda to do automated things or actions for us. And this operations account is where we have Security Hub and Guard Duty, and also Amazon Detective. And having this all pre-configured, and of course you're practicing it in your simulated game day or event response, these can reach out into your log archive account. So you can run Amazon Athena to query those S3 logs to get those insights that you need in a hurry. These accounts also link up and get access from where your workload's running. So Detective can operate into there and look at what's happening in that other account when you configure that. So let's dive into the Jupyter Notebook, and the link for this will be at the end of the session in the Well-Architected labs. So Jupyter I stumbled across when SageMaker first came out. So it allows us to have a semi-automated playbook using text and then Python code. So let's have a look. So we have the wellarchitectedlabs.com website here. So we go into security, go into the advanced labs, and then go into the I am Jupyter one. You can see our prerequisites. We just go into the step. So we need to have Python installed, Boto, SDK for AWS, and of course Jupyter. The instructions are all there. Now, I mentioned previously single sign-on SSO will help get credentials and integrate with the CLI. I'm going to show a manual way here of getting access to the temporary credentials. So this saves us from having an IAM user and access key. And it's a much safer way to get temporary credentials to use in the command line. There is also an integrated way to get it. So I've copied those credentials to the clipboard. Going to go to a CLI and paste them in. And no, I'm not going to share you my credentials. Then I can list the folder where I've downloaded the Jupyter runbook. Then I can simply run Jupyter, which starts a local web server and launches my web browser. Then I can simply click on that runbook. And then the concept of Jupyter is running blocks. So I can run this text block, which won't actually do anything, but I can read the info there. Then I can run this section on setting up the prerequisites, setting my, importing my Python modules. And then I can discover what my my CloudTrail, where my CloudTrail logs go to, because this Jupyter runbook runs from CloudWatch logs. So I can then configure my CloudWatch logs name for CloudTrail. So this is where I'm going to query the logs. Can then put an example access key in here, and I can investigate what that access key has done and when it was last used in this example here. I can then see when and who created this access key. I can then go on and see the actions that are performed by this access key. Is it just reading and writing objects from S3, or is it doing other reconnaissance activity? And there we have it. It's describing instances, it's listing buckets, it's doing actions that I'd describe as like reconnaissance activity, right? So it more than likely is being used for misuse. So we can investigate a bit further here. Right, and of course, the user-based investigation is going to search for any actions at all for that user. So both the console credentials and the access key credentials. You can then look at other recently created users to get an idea of if they're being other users and access keys are being created as a pivot point to gain a foothold into the account. We can then do role-based investigations, but because just in this example I'm using a user and access key, we'll just skip over that section. Now, containment, we can automatically, using this simple command, disable that access key. I'll just run that. That's disabled. And if this user had credentials or password to log into the console, just disabling the access key isn't enough. We could remove their password, but we could also apply this explicit deny policy. So they're not going to be allowed to do anything else in the account from now on. And that policy is attached successfully. And we can go on and do the same for a role if it was a role that we're investigating. We can also do other investigations like who's listed S3 buckets and actions that come from a specific source IP address. And you can have a look at the formatting on this and just simply build it out yourself. So there we have it. It's a really easy way to get started with semi-automated runbooks using Jupyter. And as promised, I have all the links here. We have the main well-architected link. This is where you'll find information about not only the security pillar, but the other pillars. Go check it out. The well-architected tool, which is available at no cost in the console in many different regions and languages across the globe, and the well-architected labs, where you'll find the example VPC CloudFormation template, the example web application based on static website or WordPress, as well as the Jupyter lab I just went through, and a number of great solutions if you're just getting started or want to look into more advanced concepts. So I really encourage you to check out the solutions. Just want to thank you all for your time. You're welcome to connect to me on social media through LinkedIn, or my Twitter address is there as well. Thank you very much.